Good morning, students. This is lesson 3.8. Let's get started. Okay, lesson 3.8 on page 230 is talking about the unions and intersections of sets. Okay, so first let's go into the vocabulary. There's a few words here I need you to know. The first one is union of sets. The union of sets is the total of all elements of two or more sets combined. Okay, now let's just kind of like make sure that we know exactly what we're talking about. A set is any group of things that are put together as one. Okay, now how we define a set can change rapidly from time to time. One set might be all of the things that you carry on you at any given time, like all the stuff that's in your pockets or your purse. Okay, so whatever is in there would be considered a set. Now, if you had a purse, there might be a wallet, some money, some change, maybe a debit card, maybe your phone, and a few other things. Okay, maybe a little makeup, maybe a pencil or a pen. Um, a little snack or something like that, depending on the size of your purse. But um, the idea is a set is just anything that's grouped together that, for whatever reason, is defined by its group. Okay, items in a purse, items in a pocket, or whatever. Okay, um, so the union of sets would mean that you're taking two or more sets and you're combining them. Let's say if you have a husband and a wife, and the husband has all the things in his pockets and the wife has all the things in her purse, and they dump it out onto a table, and then that would be the union of those two sets, the pockets and the purse all put together. Okay, now what would be common about them is that those are all things that people carry around with them throughout the day in order to you know have the stuff that they need to survive. You need money to purchase things or a card or something to purchase things. Okay, so continuing on, the union of sets is the total of all elements of two or more sets combined. Now, using the union diagram here, the box here, the rectangle with the little U in it, that represents the universal set. The universal set means all sets of anything put together. Set A and set B represent two different sets. I colored them in completely because I'm representing the union of the two sets. Okay, union means that everything in both sets is put together. Just like I said, if the husband and the wife dump out all the contents of their pockets and their purse onto a table, then it would be the union. Okay, now union is denoted by the union symbol, which looks like a U that has no tail on it. Okay, so if I were to write this in union notation, I would write it this way: A union B. Now, in English, that doesn't exactly sound right. You would say it differently, like A is unified with B or something like that. And this really isn't the letter U, this is just the symbol for U. Okay? I wrote a little hint here to clarify this. The letter U with the tail on it means universal set, meaning everything that could possibly be written in the box. The symbol U means union. And the symbol U, remember, there's no tail on the U. Okay? So that's kind of how you can tell it from the letter U. Now, one of the things that I have noticed about students is you ask them what time is it. Most kids will not look at the clock because I've had kids all the way through high school who say, "Oh, I can't read that clock." They don't look at a watch, or if they have a watch, it's just on their wrist for fashion, not actually for, you know, keeping time. Unless, of course, they have an Apple Watch like this. But usually what happens is the kid will reach into his or her pocket or purse and get out their phone. Okay? Now, Um, just for the purpose of our study here, I want to talk about timekeeping devices. Okay, so there's three timekeeping devices that I mentioned. We have a watch, we have a phone, and we have a clock. Okay, now I'm just using these just to kind of show how sets work. Okay, so the union of all of these sets is the fact that they all tell time. Okay, so if I said timekeeping devices, then I would include all of them, watches, phones, and clocks in one set. Okay, so you could kind of say it like this: watch, phone, clock. And then all of these sets, because I'm just talking about timekeeping devices, would kind of be considered all together. The union of them is that you're bringing them all together. Okay, but one of the things I wanted to mention would be our next vocabulary word, and that is intersection. And first, we did unions of sets. Now we're doing intersection of sets. Okay, the intersection of set is the subset of elements that is common to two or more sets. Okay, so in this picture or diagram, I have the union symbol, or sorry, the universal symbol, and I have two sets A and B, but these sets are only colored where they overlap. The overlap is the intersection, okay? And hint, um, elements, the word element means anything that is inside of a set, okay? So an element is anything that's inside of a set. Now let's go back to the example I said of the husband and wife stuff in their pockets. So the husband will have like money in his pocket, and the wife will have money in her purse. That would be an intersection. So if A represents money or A represents the things in his pocket, and B represents the things in her purse, then money would be an intersection. Now, let's just say he has one of those fancy like cell phone like holder like belt clip things. So his cell phone is not in his pocket, and she has makeup in her purse. Well, he probably doesn't have makeup in his purse unless he's a clown. And let's be honest, clowns are just a little creepy. So hopefully he doesn't have makeup in his pocket. So uh, in all of the things that are in her purse, there's probably going to be some things that she has in her purse that he does not have in his pockets. And there may be some things that he has in his pockets that she doesn't have in her purse. Okay. Like maybe, for example, his driver's license. Of course, she might have a driver's license, but it would not be his. So, and again, how sets are defined can kind of be up to the specific question or to the person defining the set. But the point is, an intersection would be the subset. Now, subset means a set within a set of elements that are common to two or more sets. Common means that we have an item that's in both sets. Okay? Now, intersection is denoted by the intersect symbol, which looks like this. Okay? Let me go down the page here a little bit just so we can see everything. Now, the intersect symbol looks just like the union symbol, except it's upside down. So if I said A intersect B, then what I'm saying is what is the same in both of these units. Okay, now let's take another example. Remember how I mentioned the watch, the phone, and the clock? Okay, let's just say that I have two different sets. Set A would be things that are portable that you can take with you. Set B would be things that stay at home, okay? You don't take it with you. I mean, in one sense, everything is portable. I suppose you could take your house or your apartment and have some guy with a big machine pick it up and put it on the back of a truck and take it somewhere. But, you know, the idea is portable things are created to go with you everywhere. Now, let's just say, for example, in set A, I have a watch and a phone because those things are portable. Well, technically, there's house phones that are not portable, but like who has a house phone anymore? I still have mine, but it doesn't cost me very much. Set B would represent things that stay in the house, like a clock. Okay. Now, the intersection of set A and set B is that these devices all tell time. Okay. So a clock tells time, and a watch and a phone tell time, but in this case, I created the sets. And the first time I talked about the sets, the union of the sets was, my definition was things that tell time. So the union of the sets is the fact that all three of these things tell time. But the intersection of this is not things that tell time. I'm sorry, let me rephrase. That is the intersection. What I meant to say is the way I defined my sets is not by things that tell time. The way I define my sets is by things that are portable and things that stay home. Okay, so the portable things would be A, the things that stay home would be B. The intersection is the element that is within the set. Since all of these devices tell time, the portable ones tell time, and the one that stays home tells time, the intersection of it is the fact that these items tell time. So I put a little T there for time. You probably can't see it. I can't really see it just because I should have drawn that bigger. Okay, but the idea is the intersection of sets is the element or elements that are common to both sets. Okay, a clock tells time, a watch tells time, but watches go with you everywhere. Clocks stay home. Okay, now what is a disjoint set? They are sets that have no intersections. Okay, so in this case I have set A and set B. You'll notice I didn't color any part of it blue. Now with this one I colored it blue, and the one on top here I colored it blue. But with the disjoint set, nothing is colored blue because these are two sets that have no common elements, okay, or have no intersection. The set of elements that that are common would be an empty or null set, okay? What do I mean by that? That's just a very odd way of saying it. So I have two sets here. I have set A and set B. Since A and set B do not have any common elements, then the set of elements that are common is empty. So in a sense, to write this mathematically speaking, rather than saying there is no set, you would say there is a set, but the set has nothing in it. Okay? Now the mathematic word for that is null. I'm sorry, that's a U, not a A. A null set. So an empty set or a null set is denoted by this symbol. It looks like a 0 with a slash through it. Okay, and that would be an empty set or a null set. Okay. Now just take, for example, a pair of Jordan shoes. Okay. And one of you knows why I'm mentioning this. I'm not going to say who. But let's just take a pair of Jordan shoes and take a clock. Okay. Now, given set A here, actually, I'll draw a new set. Set A will represent portable things. Set B will represent things that stay home. Now, set A is portable and set B is stuff that stays home. What elements might be in your house? Well, let's take, for example, oops, sorry, wrong pin. Your clock stays home, but your Jordans will go with you, okay? Now, in a case like this, I look at Jordan shoes and I look at a clock. They don't really have any common elements, okay? At least not in this definition. The clock is not portable. You hang it on the wall and it stays home, okay? But the Jordans, you put them on your feet and tie them up and then you walk away with them, okay? So they're portable. So in this case, it would be an empty set, okay? In between these two, because there isn't nothing that's common in those two items. Now, I know some of you might be doing the whole devil's advocate thing and thinking, well, there are stuff in my house that is portable or that has something in common with something else. Again, I'm just giving you simple examples just to try to help clarify this lesson. Okay, I'm not counting for every possible thing that could be in your house that is or isn't portable, or how portable do you find it where you can take the clock off the wall and carry it with you so it is technically portable. That type of thing I want to avoid. Point is, there's three different definitions here I want to clarify with you, and that is union of sets, meaning when you take all the sets and combine them together. All elements and all sets are combined together. Doesn't matter if they're the same or different, because I'm counting them all. Then there is intersection, and that means the elements that are that only exist, or that exist in both sets. Not necessarily only exist, but I have set A, which is unique. I have set B, which is unique, but I have the elements that are in set A and B that are the same. And then I have the disjoint set, which are two sets of elements that have nothing in common, okay? Now I want to remind you of the symbols, okay? There is, hold on, let me just go to the bottom of the page here so you have some room to see. There is the union set. That means everything is together. There's the intersection set. Which means that only the things that we're talking about are the things that fit into both sets. And then there's the null set, which means an empty set, or basically when the two sets don't actually have anything in common. Okay, so let me just give you some other number examples since this is a math class. And I'll just go to a new page. So just make it easier for me. Okay, let's take one set. One set is even numbers, x meaning any number that is even. And we will call this set A. Now we'll do another set, and we'll call this set B. And this will be prime numbers. Okay. Now, go ahead and draw a Venn diagram. We'll call this A and B. So for A, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, dot, dot, dot. Okay. Now for prime numbers, I have 2, 3, 5, 7, 11, 13, 17, 19, 23. I think the next one's 29, and I'll just put dot, 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 show that the numbers continue. Okay? Now, when I look at these two sets, I notice something. The number 2 is even, and the number 2 is prime. Okay? So, the number 2 would be the intersection. Okay? So, I could say the intersection of A and B is 2. Now, if I combined all of these sets, then I would say the union of A and B is all prime and all even numbers. Okay? Now, the third definition I gave was a null set. Now, in this case, a null set would be where A and B, if A and B had no intersection. I'm sorry, this one is intersection. If A and B had no intersection, then you could have a null set. But the problem is there is an intersection, so I can't really write a null set here. Okay, the intersection being 2. If A and B had no intersection, then that would be a case. Now I can give you another example. Let's say that set C is all odd numbers. Okay, now let's take a look. Set A is even numbers, set B is prime numbers, set C is odd numbers. Now almost every prime number is odd, so B and C would definitely intersect. Okay, so if I said B intersection of C is odd numbers. But let's take a look at A and C. A is even numbers and C is odd numbers. So if I were to say the intersection of A and C is null, because there are no common elements. Oh, I just realized I'm off the screen here. Sorry about that. So A and C have no common elements in the fact that A is defined as even numbers and C is defined as odd numbers. The intersection of A and C would be null, or basically meaning that there are no numbers that are concurrently even and odd. Now, you might say, but they're both numbers, so they would be combined. Yeah, but each definition for the set is what we're talking about. In this case, the sets are not defined just because they are numbers. They're defined as even numbers or odd numbers. Okay? Since even numbers and odd numbers coexist separate from each other by their definitions, then there is no numbers that are concurrently even or odd, or even and odd at the same time. Okay? They're either one or the other. They cannot be both. However, if I said even and prime, then yes, there's two. If I said prime and odd, well, yeah, there's many, because like other than two, every other prime number is odd, although not every other odd number is prime. But either way, the point is that there's several ways we can make intersections here, but in this case, there is no intersection, okay? Because A and C, basically, even and odd numbers do not have any common numbers. Okay, hope this helps, and look through the examples in chapter 3, I believe it's 3.8, and yes, so it starts on page 230. Please look through each of the examples. It'll help you more if you look at them than if you don't. Thank you much.